Hello, people. Well, I have here today, believe it or not, the universal law of numbers, and today I'm going to refer to it as the Wittekind equation, and I'm going to go ahead and solve it for us. Okay, now, when I say solve it, equations, they all have to have solutions, and I've solved a few in my day. But this particular equation, inside of it, there's an infinite number of equations. So we'll just do it the very basic way. Okay, so here we have it. Same thing. 1 second. Okay, so as you can see, I'm doing something a little bit different, basically pointing out what the values are of the numbers if we add them up going across and going down. And it's a perfect thing, so it's not a big surprise that the numbers, if you add them up going across, are going to add up to the same number coming down. And it's the number 297, and it's quite obviously a 9 number. And you see the 3 6s and 9s in all of the numbers. Predominantly 9, but 3 6s and 9s. And that's the first thing I want to point out. And of course, as always, I like to point out that even though you don't see any 3s or 6s, they're really just kind of hiding behind the curtains, but very easy to find in a game of hide and seek. So just keep that in mind. And what I did was I basically, I added the numbers, the difference between the numbers. So in the top left-hand corner, you see a 1 and a 4. So to get from 1 to 4, you would need to add 3. So the first number I have up in the corner of this one would be a 3, and so on and so forth. And we get some very interesting results there for sure. Some of them I've pointed out before. I won't be redundant about that, but you get the 248751 code, you get the 714 code, you get the 417 code, you get the 181 code, you get the ones just like you have on the original one. If you add up all of the numbers going across and going down, you get 369 numbers. Let me see. Yeah, I mean, there's just a couple of 3s there, but for the most part, there's a 6, 24 on the bottom, there is a 6, but you get a lot of 9 numbers and you get a lot of, mostly 9 numbers, but you get the 3 and 6 numbers as well. And once again, if you add the numbers going across and then add the numbers coming down, you're going to come up with the same result, which is a very interesting number, 234. Now, I can elaborate on these numbers, but you find very interesting numbers when you do this, and that's the subject for an entire different lesson, because it's really quite interesting what happens. But 2, 3, 4, well, that's a 9 number too, right? Because 2 plus 3 is 5, plus 4 is 9. And we'll move on. So I did the same thing with that one, and then I come up with this one, and all of a sudden you start seeing the 3s and 6s and 9s. You get the 2s on the top, then 396, 396, 396, followed by the code 525, 525, 525, 936, 369, right there in the middle, 693, 828, 828, 828, 666, 333, 999. I think you can recognize some symmetry in that. And as the two previous ones, if you add the numbers coming across and you add the numbers coming down, altogether they come up with the number 270, which is also a 9 number and a very interesting one. And so the saga continues, and that's why I call it the 369 code. So I'll do the next one. We're up to number 4 already. And here come the 3 6s and 9s. And now that's all we even have left. It's nothing but 3s and 6s and 9s arranged in a symmetrical alignment. And the number that we get for this one, adding across and down and putting those two numbers together, we also reach the same result of 351, which is, of course, a 9 number. 3 and 5 and 1 is 9, and we have 3s and 6s. Actually, we only have 9s now. Now they're all 9s. They're all 9s. That's right. Okay. So we'll go on to the next one, and this will be the 5th one in the series. So you understand what I've done here. I've just taken the difference between the numbers, but going forward, because there's another way to do this too, but I always carry the number forward and to come up with these numbers. Now this time we actually have something changed, because if you add up the numbers coming down, you get the 333 number, and if you add the numbers going across, you get the 351 number. But they are both 9 numbers as well, and I'm going to do a quick thing. Just bear with me. You can look at that. You can figure some things out for yourself in the meantime. I always see something new every time I look at this thing. Right. Well, if you add that 333 to 351, you're going to get a 9 number, I'm sure. 684. So that, yep, 684, which is 6 and 8 is 14 and 4 is 18, which is a 9 number. But that's just the way 9 numbers work. We already know that. And if you divide that by 9, you get 76, which is 13, which is a 4. So one of the things that I do is I take all these numbers and I divide them by all the numbers, divide them by 9, 8, 7, 6, 5, 4, 3, 2, 1, and see what happens. Okay, now we're up to the 6th number in the series, and it comes out like this. And basically, 9s are starting to take over here. And we're beginning to see something else, and that is that the difference between these numbers is always going to be 9. So that's how we get to this final result. And that yellow there line, those are 9s. So the thing actually is a 9. So we could say that the solution to this Widekind's equation is a 9. But in reality, it's a 1 because there's only one equation, and it just happens to all add up to a 9. So that will be all we will do today. Peace and happiness to the world. Signing out, Paul Widekind, once again from the University of the Universe. Have a nice day.